This wall has survived nearly 2,000 years under seawater. And the secret is not steel, but chemistry. Modern concrete often breaks faster than we expect. Roman concrete did something far stranger. It kept improving. When seawater entered Roman marine concrete, it did not destroy it. It helped build it stronger. Echoes of Time enters the lost chemistry of Rome, where volcanic ash, lime, heat, and seawater created a material that refused to die.
Rome did not just build monuments. It built harbors, ports, walls, and domes designed to outlast time.
The recipe sounds simple: volcanic ash, lime, stone, and water. But the way Romans combined them changed everything. Roman concrete was not frozen stone. It was active chemistry, still changing long after the builders walked away. Seawater entered the structure through microscopic cracks, and instead of destroying it, triggered new mineral growth. Over time, minerals like altobermarite and philipsite formed inside the material, reinforcing it from within.
That means a crack could become a repair route. The damage helped the structure seal itself.
Then Pompeii gave researchers something rare: a frozen construction site that exposed how the Romans actually built. The newest evidence suggests the Romans used hot mixing, adding quicklime to dry pozzolan before water touched the blend.
That process left lime clasts inside the concrete, tiny reactive pockets that may have powered later self-repair.
When water entered a crack, those lime clasts could dissolve and release calcium, helping the gap fill with new minerals. The result was extraordinary: a material built for the exact places where modern concrete often struggles most. Modern cement was optimized for speed and mass production. Roman concrete was optimized for endurance. The Romans may have understood something we are only relearning. The best material is not the strongest today. It is the one that survives tomorrow.
That is why scientists study Roman concrete now, not to copy the past exactly, but to build longer-lasting, lower-impact structures.
Roman concrete was not a lucky accident. It was a long-term strategy hidden inside ancient chemistry.
What looked like old stone was actually a material designed to evolve. That is why it still stands.
If the Romans could build concrete that heals itself, what other ancient ideas are still waiting to be rediscovered? Inside the crack, calcium-rich fluid begins to move. The wall is not falling apart. It is reorganizing itself. Those lime clasts were not defects. They were reserve material, waiting for water to activate them. The pores gave water a path. The chemistry gave the path a purpose. Every wave that should have destroyed the wall instead fed the process that preserved it.
Seawater became part of the structure's future, not just its environment.
Over decades, mineral growth tightened the structure from the inside out.
That is why some Roman marine structures still outlast modern expectations by centuries.
The crack opened first. The repair began second. That sequence is the secret.
Even in ruin, the material still tells the story of its own survival. And when you rise above the waterline, the impossible truth remains. It is still there.
The newest clue suggests the Romans used hot mixing before water touched the blend.
That reaction released heat, changing the mortar before the builders ever placed it.
The recipe was not cold and passive. It was active, hot, and deliberately unstable.
Those white fragments survived the mix and became the hidden engine of later self-repair.
To the eye, it looked like ordinary construction. Underneath, it was controlled chemistry.
Layer after layer, the Romans built foundations that could survive the sea's patience.
The process was rough, loud, and physical, but its result was remarkably precise. Every channel, every pore, every fracture path was part of the design.
What the Romans built was not just concrete. It was a system.
And systems survive far longer than simple materials. Pompeii gave researchers a rare gift, a construction site frozen before the work was finished.
The site preserved the materials exactly where the builders left them. Those samples revealed lime clasts that matched the hot mix hypothesis. The structure itself became the evidence. The Romans were moving ingredients in bulk, not guessing at a miracle.
Reaction rims around the aggregates showed the mortar had been chemically active from the start. Field evidence and lab analysis began to point to the same answer. Pompeii did not just preserve ruins, it preserved a method. That method explained why some Roman concrete may have healed itself after cracking.
And suddenly, the old mystery stopped being poetic. It became testable.
Modern concrete often fails because the environment attacks it faster than it can recover.
Steel reinforcement solves one problem, then creates another.
Once the cracks begin, the damage usually accelerates. That comparison is what makes Roman concrete so important today. Scientists are studying Rome not for nostalgia, but for answers. The goal is not to copy ancient Rome exactly. It is to learn what made it durable. Long-term resilience matters most where the sea never stops moving. That is exactly where modern infrastructure needs a better material philosophy. Rome built for centuries. Industry often builds for the schedule. That difference is why the Roman story still matters. Roman concrete depended on volcanic landscapes that gave the empire its hidden advantage. Pozzolan was not just a filler, it was the chemical backbone of the mix.
Quicklime came from fire, turning stone into something reactive.
That reactivity was dangerous, but it was also useful. The entire supply chain was built to move the right chemistry to the right place. Every ingredient was selected for a long-term outcome, not a quick one. The moment they mixed it, the material began changing on its own. Rome's ports were not just destinations. They were part of the production line. Construction was a chemical choreography played out in stone and fire. The empire built infrastructure that could feed the empire back. Under the microscope, Roman concrete reads like a geological time capsule. The minerals inside it tell us how the material evolved after placement. That slow mineral growth is a major reason that the material could become stronger over time. Different minerals work together inside the pores, reinforcing the matrix from within. The contrast with modern concrete is not just visual, it is structural. Every repaired zone is evidence that the material kept responding after the fact. That response is what makes Roman concrete so rare in engineering history. The more scientists look, the more complex the Roman recipe becomes. This is not a single trick. It is a layered strategy. And that strategy still challenges what we think concrete can be. But there is no single Roman recipe used everywhere. The Romans adapted their methods to local materials, climate, and purpose. That flexibility is part of why their engineering was so effective. In some structures, the same chemistry supported weight, span, and weather all at once. The empire shared knowledge, but not always a single formula. Text and ruin together give us hints, but not the whole answer. That uncertainty is not a weakness in the story. It is the story. Every scar in the material is a clue. The Romans left us not just structures, but a puzzle that keeps getting deeper. And the ocean is still holding part of the answer. Modern construction is beginning to ask the right question: how do we build for decades, not years? Roman concrete offers a roadmap toward more resilient, lower-impact materials. If a material can self-heal, the cost of maintenance changes completely. That could matter as much for sustainability as for strength. The future may not be a perfect copy of Rome, but it may begin with Rome's ideas.
Nature rewarded the Romans' chemistry. Engineering can learn from that partnership.
Durability is not a luxury. It is the difference between short-term building and long-term civilization. Every coastline on Earth is now a test of our materials. Rome passed that test long before we wrote it down. Roman concrete still stands. What ancient mystery should we uncover next? Subscribe and share your answer in the comments.